I will just put the screen where we stopped last time. Can you all see the PowerPoint? Can you all see the PowerPoint?
Yes, sir.
Yeah, right. Could you remember last time we have talked about variability? We talked about variability. We discussed about the term called as variability. So this variability we discuss about the term called as variability. Let me. So the term called as variability, right? We discussed about the variability and we took an example and went through how we can calculate the variability very briefly. Today we might see in a long, how we can see the variability. Right. When you look at a particular variable, if you measure the observation of a particular variable again and again repeatedly, you can see the value that you measure is always a different value, right? You will have a random value, a different value. So that when you want to make a decision, if you want to make a decision, you cannot come to a decision based on one value, right? Therefore, since there is a variability, we need some statistical tool for decision making process. We need some statistical tool for decision making process, right? So under that circumstance, when you say constant, if you measure repeatedly, if you get a constant value, a value which is not varying at all, then no point of using statistics. You can make any conclusion based on that one value, which is a constant, right? But here, in naturally, you don't get a constant value repeat if you measure repeatedly. As I pointed out last time, if you do what you call titration, if you do a titration using a burette, right, using a conical flask, right, so you might get different readings if you repeat it. Let's say I have 5.5 milliliter as the endpoint at the first observation. If you repeat the same titration again, I might get 5.8 milliliter. Then if you repeat further, sometimes you may get another reading as an endpoint. So you see here, this solution here, it is same. The solvent here, it is same. Everything is same. Everything is same solution. But your endpoints are giving a different milliliter values. You see, this is the speciality of the variability. So that here we cannot make a conclusion whether it is 5.5. Can we make a conclusion saying 5.5? Or can we make a conclusion 5.8? Or can we make a conclusion 5.9? We cannot, because the numbers are varying. So that is why we need a term called as statistics. That is why we need a term called as statistics. Okay. Yeah. Can you all see the board clearly?
Yeah.
Yes or no?
Yes, sir.
All right, fine. So that is why, as I pointed out, you need statistics. So variable, the observations take different values. Therefore, if you have a case variable, one observation may not be good enough to make any conclusion, so that we need to have more than one observation, right? We need to have more than one observation for any statistical conclusion to be drawn, right? We have seen maybe very quickly this slide also last week. Because of this variability, at least several values are required to make the conclusion about a variable. Do you agree? For example, in this case, we need to have several values, more than one values, to make a conclusion. For the conclusion to be exactly correct, it is required to have the a proper data collection. So we need to have data collection, proper data collection, right? Right. Today we are going to introduce a term called as population. Look at the third paragraph, population. I will come to that. A collection of all the values under a given study is termed as a population. So what do you mean by population? It's the collection of values under given study, right? For example, in your class, how many students are there? In your class, how many students are there? Batch rep Jeffrey is not around, I think.
83.
83 students are there in the whole class, right? Right, fine. Now, I am going to study the average height of the students studying at third year in the Faculty of Agriculture, University of Jaffna. Can you all see these letters? Can you all see the letters?
Yes, sir.
Yes, sir.
Right. So we want to, this is my objective of my study. I want to study the average height of the students studying at the third year in the Faculty of Agriculture, University of Perak. So who are the people that I am going to study? Who are the people that I am going to study? I have a name list. I will come with that. I have the name list. I don't know where did I stop last time. Sivakumar, Tanush Kumar.
Yes, sir.
Are you
I'm
around,
here.
Sivakumar? Yeah, Tanush
Yes, sir.
Kumar.
Yes.
Yes. Tell me if I say I want to study the average height of the students studying at the third year in the Faculty of Agriculture, University of Perak. Sorry, University of Jaffna. Who are the people studying at third year now at the moment?
We.
Exactly. So what is the total number of students studying at third year Faculty of Agriculture, University of Jaffna?
86 people, students.
Exactly. So 86 students who are studying at the Faculty of Agriculture, University of Jaffna, I mean the third year students, right? The whole third year students are called as population. right? Whole third year students are called as population. Right, now I will say, rather than saying average height of students studying at the Faculty of Agriculture, University of Jaffna, I am changing now my objective as getting the average height of the students studying at the Faculty of Agriculture, University of Jaffna. Now, what is the population? What is the population now?
I don't know the actual value, but for the whole batches students,
Yeah, which batches? First year students,
first year, second year, third year,
third
and
year.
final year.
Exactly. So you see, now the population is larger, isn't it? Now the
Yes.
objective is different. Now I am going to study the average height of the whole faculty students studying in the faculty. Earlier I had only third year. My objective was studying the third year students. Now I have studying of the whole faculty students. Now you see the different population. You see? So that is called as population. Now this is also called as population. So this population, the demarcation of the population depends on what are we going to study. It depends on our objective, right? Okay. So population, that is how we call it as population. This population, right, is the collection of data. Look at the third para. It is the collection of data, right? A population is the collection of data whose properties going to be analyzed, right? Whose property is going to be analyzed, right? So we are going to analyze the properties of these students. So we take the whole group, which is called as population, right? So this term population does not mean only with human beings, right? This can be deal with anything, maybe plants, animals, insects, anything. Okay, so generally it is called as population, of which that we are going to make a study. That is called as population. So the population is a completely collection to be studied. It contains all the subject of interest. So subject of interest is here the average height in this case. So all the interested item that can be studied for the interested what do you call interested variable, then can be considered as population. Yeah, collection of data from the whole population is not easy. So now, if I say this is my objective, I want to study the average height of students studying at the Faculty of Agriculture, University of Jaffna. Right? Now, Krisha, are you around? Krisha, are you around?
Yes, sir.
Okay. Krisha, now could you tell me uh, roughly what could be the number of students here? First year, second year, third year, final year. Let's assume the total number of students is, let's assume for the time being as 400. 400 students are studying at the Faculty of Agriculture in all the years. First year, second year, third year, and final year. Krisha, are you okay? Understand? Right. Now, tell me, if I ask Krisha to submit the assignment, finding out the average height of students who are studying at the Faculty of Agriculture, I'm giving only 2 days time. I'm giving only 2 days time her to study this, Krisha. Right. Now, can somebody, not only Krisha, others also can answer, can somebody tell me, will it feasible, will it possible to measure the height of how many students do I need to measure the height? For how many students do I want to measure the height to make a conclusion as average height for the Faculty of Agriculture?
400, sir.
400 students. So I'll have to measure all 400 students. Practically, will it possible to measure all 400 students within 2 days? Practically, will it possible?
No.
No. Why? What could be the reason? Some might be absent to the class. Some might be at home. Right? Yeah?
Yes.
Yes. Then what else? You cannot reach each and every individuals due to various reasons. Right? So you cannot sometimes take the count of all these whole population. That is what we said, the whole population, right? We cannot sometimes take the count of the whole population. The whole population in this, our example is 400, but 400 is fairly a small number, right? Isn't it? 400 is a fairly small number. Suppose, let's say I want to measure the average height of students who are studying at University of Jaffna. Then how many students falling into the population? How many faculties are there?
10 faculties.
Yeah, so you see, in each faculty they have first year, second year, third year. Some faculties have 4 years, some faculties have 5-year degree program. So you see, the population become very large. So in that case, what you would do? Then it is a difficult task. So in that case, the term called as sample coming into play. So you see the term sample, right? The term called as sample coming into play. So since I'm unable to get the information from all the students, what I do is I'm going for sample. Right? I'm going for sample. I have simply written as sample, SAMPLE. Right? Same thing what is appearing on the screen. So this is sample. So since I am unable to study the whole individuals of the population, I am taking part of it, which is called as sample. Therefore, a fraction of population is going to be studied, and this fraction is called as sample. Is it clear? So the sample is actually a fraction of a population. Right. This is a typical definition there. Right. Typical definition is there. Right. Population is the set of data, numerical or otherwise different types of data, we will see later, corresponding to the entire collection of units about which information is sought. Right? So the population is the whole individuals in a study. Right? It is the set of data corresponding to the entire collection of the units. Entire collection of the units, which gives the information that we are going to sort it. That means, for example, in this case, height. We want to measure the height of all the students. So that is called as population. And sample, as we said, right, before coming to sample definition, in population also you have 3 types. We can divide. This is arbitrary kind of definition called as finite population, infinite population, countable infinite population. Look at this example. Average height of students studying at Faculty of Agriculture, University of Peradeniya. Sorry, University of Jaffna. I always remember Peradeniya, right? University of Jaffna. Can you count how many students are there studying at Faculty of Agriculture? Can we? Yes or no?
Yes, sir.
Yes, it is a small number. Even though it is a population, it is a small number. Only, as you all said, 400 students. So that is simply called as finite population. That is simply called as finite population. Easy to recognize the whole individuals of the population. Suppose infinite population. I am saying average height of students studying at the universities in Sri Lanka. Average height of students studying at the universities in Sri Lanka. How many universities are there in Sri Lanka? Hmm?
14.
Huh?
41, sir.
41. Are you sure? How many government universities are there? Government registered under the UGC. The allocation is given by the UGC. How many universities? Anyone?
14. 14.
14, yeah. Roughly about 15 universities are there. That is coming under the UGC allocation. When I said the universities in Sri Lanka, I didn't mention about which type of universities. There are more than 15 universities. 15 is coming under the UGC. Another 20, 30, 40 universities are there. Right? Can you give an example? Another university?
Late.
Exactly. Sleep, SciTum, this and that, A, B, C, D. You have plenty. So now, I said average height of students studying at the universities of Sri Lanka. Any university. So what is the next thing? You have several universities. In each university, you have undergraduate and postgraduate. Because I didn't say undergraduate student. So you have undergraduate, postgraduate. Then we have different years, more than 100,000, 200,000 students studying at the universities. Right? Plus, what else happening? Every day at postgraduate level, students are registering, students are graduating. So we don't know exactly what is the number coming and going. For example, I'm at Postgraduate Institute of Agriculture. Today there were 2 postgraduate students who graduated. You see? So can we find out exact value then? Difficult. Right? When I said the studying average height of students studying at universities of Sri Lanka, finding the names and information and getting information from all the students are very difficult. So that kind of situation is called as infinite population. Right, now I will give another example. The insect population, let's say, have you seen cockroach in your dormitories? Maybe in your first year, second year? Haven't you never seen a cockroach in your dormitories or the residing place?
See, sir.
Huh? Cockroach? In Sinhala, it's Karapottan. In Tamil, same thing, Karapottan. Haven't you seen anything? Yes or no? Otherwise, we will have to teach entomology then.
Yes, sir.
Hmm? Yes, you have seen. Now, I say I want to do a small study, the cockroach population. I want to study about the cockroach population in Arvial Nagar. I want to study the cockroach population in Arvial Nagar. Or I want to study a flies population, Ilian, Masso, in Arvial Nagar. So you have plenty in your canteens, you could see, right? So can you tell me exactly that we can make a count of all these insects living in Arvial Nagar?
We can't, sir.
We can't, because these are kind of imaginary numbers. Later we will see, we can estimate them, but we cannot find the exact number. So that is called as infinite population. Let's say apid population in Kilnochi. Can you find out the total population? Apid population in Kilnochi. Very difficult. Cattle population. I want exact number. Cattle population in Kilnochi. We can't find exact value because death, birth every day happens. No records in some farms. So a lot of problems, right? So those situations are called as infinite population. The last one is called as countable infinite population, where it's look like a infinite, but with the time and the cost, we can count the number. For example, if I say uh, if I say I'm having a let's say 1 metric ton of paddy seed. One metric ton of paddy seed. Can you all see what I have written there? If nobody answer, at least Batchrep has to answer.
Yes, sir.
Yeah, you can see, right? So my question is, I'm taking 1 metric ton. 1 metric ton means how many kilograms? 1 metric ton of paddy.
1,000 kilograms.
1,000 kilograms, right? I'm taking 1,000 kilograms of paddy seed. Now I am asking some of you to count how many paddy seeds are there in this 1,000 kilograms. Can we count it? I'm asking how many paddy seeds in this 1,000 kilograms.
Can count, sir, but difficult.
Yeah, we can count, but only problem is it takes time and it involves some level of cost as well, right? Time as well as cost. So that kind of situation is called as countable infinite population, right? Countable infinite population. Right, now we come to the sample. Sample is I have already defined what is sample. We cannot study the population as a whole. Therefore, we go for sample. Sample is the subset of a population. It represents the population. It is called as subset of a population. So sample is a subset of a population, representative sample, right? So that means the samples are representative of that particular population. You have to be a little careful when you take the sample. We'll have to take from that population only. Later we will see some of you might do some questionnaire survey in your final year research, so that when you do the sampling, you have to be a little careful, right? So that sample should represent the population. Otherwise, whatever you estimate will be not a good estimate. So you'll have to have a good estimate. To have a good estimate, the sample should be from that population. So we call it as this sample should represent the population. Okay, sample should represent the population. So representative sample. So the samples has to be representative, has the characteristics of the population. So they should be representative. And what do you mean by this representative is that they should have the same character as the population. Otherwise, no point. It's like measuring the income of Mullaitivu district, right? So you ask to measure the average income of Mullaitivu district, right? So what people do is from Kilnochi, Arvial Nagar, I will have to travel to Mullaitivu district to get the sample. So what I do is I will go to the farmers among the Kilnochi district and take the information. Then I will represent it as this is from Mullaitivu district. Do you think it is a correct way to do that? Statistically, it is wrong, because you have not sampled the Mullaitivu district people, farmers. You have sampled the Kilnochi district farmers, whereas Kilnochi district farmers might have more income than Mullaitivu or less income than Mullaitivu. That we don't know. So that will not represent the population. Okay. So the sample is very important, which is representing the population. Right. This is the question that I asked earlier. Why we want to go for sampling? Right? Why we want to go for sampling? In most studies, it is difficult to obtain information from the entire population, which I said earlier. Suppose if you ask to measure the average height of 400 students in 2 days, then we don't have a chance to measure all the students, right? So in most of the studies, which is difficult to obtain the entire population of a particular study, right? For various reasons. Therefore, we rely on sample to make estimates or inferences related to the population. We'll talk about these two terms, estimate and inferences, right? Estimate and inferences, we'll talk about that later. So these are the overall statistics aim on. We try to estimate and we make the inferences. We make, based on the inferences, we come to the conclusion, right? So statistics are basically derived for getting the value or getting the information for estimates and inferences, right? Right. The summary measures of population is termed as parameter, and the corresponding value from the sample is called as estimate. So what I said is corresponding measures that you are taking so basically we studied about population. So we said about population, right? We take the sample, right? We take the, this is a population. We take a subset of population, which is called as sample. So here, two terms, whatever you calculate from sample is called as estimates. Whatever you calculate from sample is called as estimates. Whatever coming from population is called as parameter. Can you all see the board?
Yes, sir.
Yes, okay, fine. If you don't see anything properly, just tell me. Yeah? I will, any chats? No chats, I will. Just a second. Huh? Yeah, no, if you have anything, you can write to me also. But I will see time to time on the chat. Right. Any questions? So whatever you do the summary based on the population is called as parameter. Whatever the summary that you are making from a sample is called as estimate. Right? So hereafter, if I say estimate, you should know it is coming from sample. Parameter means it is coming from the population. So you know the difference between population and the sample. Right? There are a number of ways drawing sample. So now the population is a bigger group. Now we are going to take a smaller group from this bigger group. So there are so many ways to take the sample. I will very quickly glance what type of samplings are there. So sample from a population, the key objective of all these sampling methods is to obtain the representative sample. That is what I said earlier also. The sample should represent the whole population, right? Unless the sample is representative, this is going to be, all right, unless the sample is representative, an unbiased and precise estimate cannot be made. So that means if the sample is not representative, how do you call then that estimate? If the sample is, as I given the farmer income from Mullaitivu and Kilnocchi. So we want to study the average farm income of Mullaitivu district, but we took the sample for easiness. We didn't go to the Mullaitivu. We took the sample only from Kilnocchi. Do you think it is a good study? Will it represent the Mullaitivu? If people are silent, I'll have to be speaking out with name. Kirija. Are you around, Kirija?
Sir.
Yeah. Can you answer my question? Yes, Kirija?
No, sir.
No, it is not going to be representative. Why? Because you need to study the average income of farmers from Mullaitivu. But you took the sample from Kilnocchi. Totally contradiction, isn't it?
Yes, sir.
So it is not going to give the results what we expected. It is going to give the some result. Definitely it will have some results, but it is not going to represent the Mullaitivu farmers. So that kind of phenomena is called as biased, right? That kind of phenomena is called as biased. And unprecise. Biased and unprecise. Precise mean it is correct, right? Unprecise mean not correct. It's going to be biased as well as unprecise, right? So to have a good estimate, the sample should be representative. Okay, the sample should be representative to have a good estimate. Right, now I said sampling. From population, I can draw a sample. right? From population, I can draw a sample. Actually, if you go for a higher studies, Master of Statistics, then this sampling, different types of different ways of sampling is 30 hours of lectures, where I'm going to talk about this very briefly in 10-15 minutes, right? Just to introduce what is sampling. Simple random sampling. What is simple random sampling? What is random? Anyone? What is random? In Tamil, it is called as Eluthamanama.
Pick one thing.
Yeah, go ahead. Yes, random.
Pick one thing from a sample whole population.
Yeah, that is okay. Picking one thing from the whole population, that is okay. But what do you mean by random?
Examples from here and there from the population.
Once again, partially correct. I couldn't hear properly.
Pick various samples from that population from various.
Yeah, it varies from population. That is true. What do you mean by random?
It takes from here and there.
Here and there, fine. So how statistically we call it as? For example, if I want to select 10 students from our class, I mean your class, to measure the height, right? If I select only beautiful girls and handsome boys, counted for 10 numbers, do you think it is random? Yes or no? Is
No,
it
sir.
random? No, it is not random. It is purposely. Purposefully, I have chosen those 10 numbers by looking at their faces. That is totally non-random. That is biased, right? Random mean, as somebody said, picking here and there. In simple term, that is how it's called. But in statistically, we will have to say random mean each object in the population will have equal chance to be selected, isn't it? Each member in that population will have what chance? Equal chance. Everyone has equal chance to be selected. So that is the concept of, or the principle of random sampling, right? So the simplest form of random sampling is called as
Excuse me, sir.
simple.
Last class I'll ask the probability, maybe the random sampling. Sir.
Oh, no, probability. Don't mix things. Probability is something different. I will come to that. Random sampling, because every will have equal probability. That is true. Every will, because in simple term, I said that everyone has equal chance to be selected, right?
Okay, sir. Thank you, sir.
Everyone have equal chance to be selected. Let's say in your class, how many students are there?
86, sir.
86. So let's say you have first student, second student, third student. You have 86 students. Can you see the board?
Sir.
Can you see the board?
Yes, sir.
Yes. So you see, I have first student, second student, third student, and goes up to 86. Now, if I ask you, what is the chance of occurrence of these students to be selected, then the probability come into play. Don't mix now. It's too early to talk about probability. We will talk about probability. So they have equal chance to be selected. So if I say what is the probability of this, let's say this is the first, what is the probability of first person to be selected? 1 out of 86. The total number of students is 86. So he is having a chance of selecting as 1 out of 86. So this is called as probability. Don't mix. I didn't talk about the probability yet. What about the chance of selecting the second student?
1 over 86.
Yeah, that is also 1 over 86. What about third?
Same, sir.
Everything is same. So if you add the total probability, it should be equal to 1.
86.
It should be equal to 1. 86 over 86.
Yes, sir.
So total probability is 1. So this we will learn later. It's too early for us to learn now, right? We will learn the basics. So every member has equal chance to be selected. So that is basically the concept of simple random sampling. So the simplest form of the random sampling is called as simple random sampling. Okay. I have some elaboration for that. Objective of this simple random sampling is select n number of units from the capital N number of units, right? Capital N means it is the total population. From the population, for example, in your, if you want to find out average height of students studying at Faculty of Agriculture, University of Jaffna, what is the capital N? What is the capital N? The population. What is the capital N?
400.
400. The value of capital N is 400. We'll have to decide what would be the simple N, that is the sample size, right? Selecting small n units is the size of the sample, maybe 10, 20, 30, that is sample size, right? So selecting small n units of number from capital N units from whatever the object that we are planning from the population, they have equal chance being selected. So this is what I said, equal chance being selected. Okay. Right. This is more important procedure. How we can do it? Let's say 400 students. Out of 400 students, I want to select only 10 students. What is the simplest form? I have 400 students in the faculty. I have 400 students in the faculty, right? Can you all see me? Which I say is as capital A. I want to select 25 students, which is simple A. I want to select 25 students. What is the simple procedure? Practically, how it's possible?
Select 5 from each.
Derive 5 from
Each, yes.
each year. Fine. Anyone else? Her idea is because derive 5 or 6, because only 4 years are there: first year, second year, third year, final year. If you derive only 5, we have total number is 20. Arosha?
We can't exactly, but we can select 6.
Yeah, we can select 6 from one batch. Is that what you are saying?
Yes, sir.
Right. What is the problem here? What is the problem here? Your answer is partially correct, because here we didn't give equal chance to everybody. Why? Why equal chance to everybody, not equal chance to everybody? Can you guess? Everybody means this whole 400 students. They are not having equal chance. Why? Can somebody answer? There is what Arosha said is one technique. That is also possible, but that is not good example for what we are discussing now. Random sampling, not equal chance. Why? Why is that? Do we have an equal number in all batches? Do we have equal number in all batches?
No, sir.
Arosha?
No, sir.
No. In your batch, for example, 86. Maybe first year, there may be 150 students. So what is the problem then? If there is no equal number among the batches, then what is the problem? What is the problem?
Separation is tough, sir.
Yeah. So this number is not going to be same for all the members, isn't it? These probability values will differ from batch to batch. So every member will have different values. Do you agree?
Yes, sir.
So the probability can change. So that is not our objective. If every batch is having same number of students, then we can say. But every batch doesn't have the same number, so that we cannot do it like that, as Arosha said. So what is the technique possible? Simple technique. Simple technique. Don't think too much. Simple technique. So this is capital N. This is simple N. What I do is I have first name of the first student, second student, third student. How many students are there? 400 students. Can you all see this value?
Yes, sir.
Yes. 1 to 400 students. Their names are there or registration number, whatever it is there. So what we do is, in a small piece of paper, I write down the registration number. What is your, how do you write registration number? AG? Batch? How do you write? The number, let's say 01 of, how do you write your registration number? 2020 or whatever it is. This is the registration number of first person, second person. So write down the registration number. In another piece, sorry, this is 2. Likewise, this is the third piece. Do you understand? So we'll have to write down 400 pieces, indicating all 400 students, and put this into a box. Right? You have chips. Put all these 400 chips. 400 chips are there, indicating each of the name. Right? Now you take one by one. Sorry, you take one by one. First chip, then you have second chip. Take the chips one after the other. How many chips do I need?
25.
25.
Yeah,
25.
exactly. So up to 25, I can go. Take one chip after the other. Take 25 chips. Right? So that is the best way to do the simple random sample. In this case, there may be more students coming from one batch. Will it possible?
Yes, sir.
Yeah, because randomly we are selecting. So more students from a particular batch, not like in the earlier case. Earlier, Arosha said 6 students from each batch. So that we are restricting. But now we are not restricting. From one batch, more students possible. Similarly, what is the other thing?
One batch may be no student, no any student.
Pardon?
One batch may be no any students select.
Yeah, that is rarely we have that chance, but possible is there. Right. Now, what is the other side of the coin? In your class, in your batch, or in Faculty of Agriculture, University of Jaffna, do you have only unisex faculty or bisexual faculty?
Bisexual.
Bisexual, male and female, isn't it? Isn't it?
Yes, sir.
Right. So now when you select this 25, there may be high chance more, let's say, out of this 25, after doing all this drawing, I got 20 female as a sample, then 5 male. Is it a good way to select it? Because it is possible. That is what I am saying. When you go for randomness, this is possible. You have selected 20 students as a female and 5 as male without knowing to you, your knowledge, right? Because it is random. Is there any problem here? Is there any problem selecting students as such? Yes or no? No, I mean not selecting. Is there a problem in the outcome? 20 versus 5.
Sir,
Yes or no?
if the highest person include the neglected one, what will happen?
No. I'm asking in that sample selection, my samples happen to be 20 female and 5 male. Do you get the point? I selected randomly 20 female and 5 male. So if I measure the average height of this 20 female plus 5 male and give the results as the batch results, do you agree with that?
No, sir. It's gender based.
I couldn't hear.
It's maybe problem, sir, because
Why?
the average mean the maybe girls and boys height is varies.
Yeah. You are hitting the point, but not correctly. Yes. Can you elaborate a little bit? Yeah, I will guide you. Yes, what you said is partially correct because genetically, girls,
Female.
girls do not agree with me if I say that females are genetically, on an average, their height is lower than the male. Do you agree? All the female students in the class, do you agree? There may be one or two exceptional cases, but I'm talking about on average. On average, genetically, the females are shorter than the male. I need the answer from not from males, but from females, accepting that fact.
Yes.
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 Generally, I'm talking. Look at your family background, father, mother, in general, brothers, right?
So
So
excuse me,
that
sir. If we select one parameters, shall we take the like two parameters? Can we mix, sir?
no. Now I am talking about.
I mean, my question is, sir, the girl boy gender based one parameters
Mhm.
and the height is one parameters. In the
No.
average, we consider average height of students population. So
Yeah.
why we consider the male and female? Sir? That's the
That is a little bit different sampling technique. I will come to that here. I mean, your notes is there. You can read the notes. That is the second type of sampling. I will come to that. I'm hitting the point there, right? So here, uh, just give me a second. I want to plug this power supply. Check. Let's see. I want to check the power supply. Yeah? Now it's okay. Right. Okay. Okay. Yeah. Okay. We will continue. Yes. We will come to that type of sampling a little later, because here I just discuss about suppose if you do random sampling, if you have 20 female and 5 male, that is possible. That is possible. Normally, in your batch, what is the percentage of male and female? Maybe 60% female and 40% male, right?
Yes, sir.
Yeah. Huh?
Yes, sir.
Yeah, roughly 60% female. Nowadays, 2/3 is female, 1/3 is male. But this proportion, 20 and 5, does not represent as such. So we have a problem, right? So that is what I want to highlight here. When you go for random sampling, this kind of problem may occur, right? That is also possible. There are solutions for that also. We will come to that when we do the other sampling, other type of sampling. So usually the procedure is, you see there's a random table. There's a table available which is called as random table, right? Even random tables are, random number tables can be created in a scientific calculator. In scientific calculator, you have the random numbers, or we can use computers for random numbers to select the random numbers. Because in earlier case, what I said, we want to put the names of all these students in different chip and putting into the box and taking one by one. That takes a longer time, isn't it? That takes a longer time. The simplest, you have the name list, you press the computer for random number, it will give number 30. Then you select the person having the number 30, right? Then if you go for the second press, it will give 88. So the second person that you should select as a sample is the name with 88 number. So likewise, you can select it. So that is the simplest way nowadays available, right? Rather than writing down a piece of chip, right? So these random numbers can be created using normal calculators or computers, or even random tables are available. If you type it random number tables in Google, you get different types of plenty of tables. Or a mechanical device to be selected as a sample. All these are possible. Sorry. Right. In a simple expression for random sampling, you can see here, this is the population. As I pointed out earlier, this is the population, right? This is the population, right? So in the population, you have different objects. So from that, you are going to take only one object or few object out. So that is called as sample, right? This is called as sample. Is it clear? So population, in population, you see this B is already there in population. Where? You see, it is already there in population, right? T is already there in the population. K is already there. G is already there, right? Now, if I say one more thing, if I have F also in the sample, right? If I have F also in the sample, do you think this F is coming from the population?
No, sir.
No. You see, this is what we said. The sample should represent the population. So here, F is not representing the population. So it has come from somewhere else, right? So this kind of mistake, we shouldn't do it, right? So this F is actually not coming from this particular population. So the probability selected, which I have already given, depend on the how many elements that we are going to select versus the population. So this is the element, right? This is the element, this is the population. Small n is the element, capital N is the population. When the population is rather uniform, so here we are coming to the point that we made a small comment earlier. Population is rather uniform. Under that circumstance, we can apply the simple, I'll put it as simple random sampling. So in simple form, SRS means simple random sampling. We can apply simple random sampling under which situation? When the population is uniform. What do you mean by population uniform? In early example, we took 20 female and 5 males. Is that population uniform?
No, sir.
No. For example, in your class, we said 60% of the population is girls. Only 40% is boys. The population is not uniform. Why? Because already the character that we are measuring has an influence on the population. What is the influence? Already we said on an average, the height, average height or the height of female is less than the height of male in general. So already this phenomena is affecting the population. So the population has to be uniform. Then only we can apply this simple random sample. Examples, the school. When you say school, can we apply Royal College and can you apply the same concept for Royal College and Kilnochi Madhya Mahavidyalaya? Can we apply the same sample, same concept for Royal College and Kilnochi Madhya Mahavidyalaya? Yes or no? No, because Royal College, there are some gradings in the schools. How many of you know there are grades in the schools? Grades, A grade, B grade, C grade, B1, B2, and so on. So we can compare the same grade school. Royal College is coming under the A grade school. So you can compare only A grade schools, Andhra College versus Royal College and so on, when you talk about sample. So then uniformity is there. But comparing higher school and the lower school, the uniformity is not there. So you'll have to be a little careful. Students, college students, income, as I said, income, ethnicity, etc. So when you talk about even if you take income from Colombo, I'm going to study the average income in Colombo. Oh, let's say average income of farmers in Kilnochi district. Can you all hear? All are sleeping, huh? Having a very heavy food.
No, sir.
Huh?
We can hear, sir.
Ah, right. Good. So now say I'm going to study the income of Kilnochi district farmers. Can we treat all the farmers at equal level in terms of collecting sample? Yes,
No,
sir.
sir. No,
No.
sir.
Why?
Because some farmers are small scale farmers, some are large scale farmers, so we can't
That is
compare.
the problem, because some farmers are having a small land extent, some are having large land extent, some are having machineries, some are having only cattle or buffaloes for plowing, etc. So you have different levels. So these different levels will determine their income ultimately. So this we'll have to have different categories: high income farmers, middle income farmers, low income farmers, or maybe farmers with a high land area, middle level land area, or low level land area. So likewise, you have some category. We cannot pool them the whole farmers, right? So these are some of the problems in random sampling. As a solution for this random sampling, other type of samplings might come. Right, but on the other hand, this simple random sampling is it is the simplest and fastest and the cheapest. Right, could be unreliable. Why? Because this simple random sample is could be unreliable if the population is not uniform. If the population is uniform, as we said, no problem. In their class only males are there, we can measure the height without any problem by selecting any number. But if you have equal proportion, male and female, no problem. But if you don't have equal proportion, then we have a problem. Why? As we already pointed out, males are taller than the females, right? So the other thing is sometimes it is unreliable when you follow the wrong procedure, right? What do you mean by wrong procedure? Maybe once you come to your final year research, you may see what is the wrong procedure. Now, say I want to select the same example. Have you heard about GN division? Have you heard about GN division, Grama-Niladhari division? So in a Grama-Niladhari division, normally you get roughly about 500 families. Let's say I have a GN division, whatever the name, doesn't matter. I have 500 families. I want to select 25 families from this 500 for sampling. So how I select it? I want to talk to only 25 families for the data collection out of this 500 families. How do I select? Miss Marianayagam, are you around?
Yes, sir.
Yes. How you can select 25 household from this 500 from a particular GN division?
By select randomly, choose one in the list. We choose one by one or two.
Yeah. So how do you get the list? You are right. You are right. Right. How do you get the list of names of all these 500 people? Where we can get the list?
In the DS office.
Exactly. We can get the list from the Grama-Niladhari division. So we get the list 1 to 500, right? The names are there. Their names are there. Mr. So and so names are there, right? So now I have selected. I have got the list. How to select this 25? Soulmita, how to select this 25 in a simple technique? Again, I can use the same way as I did earlier, writing down all the names and putting into the box. That is take time. Otherwise, randomly I can select. Right, I have selected some names. Let's say 33, number 33, 58, 72, 104. So likewise, I have selected some numbers. This is the first sample, second sample, third sample, and the fourth sample. Now, I go to the house with the name appear here, right? And do the sampling and so on. But what we do is normally, how many of you have involved with some sample survey? Let's say if you ask to do a sample survey, let's say this is the main road. Huh? You have house. All right. You have house here. Also, you have house on the other area. And just putting it as. Huh? Then you have some sub-base, for example, right? Let's say this house 104 is somewhere here. So we'll have to go to this house. You are sampling taking place during a rainy season. So this road is full of mud. This road is full of mud. You are taking sample in Kilnochi district, let's say. This road is full of mud. So what you will do, simply. This is the house number 104. So that is also included in the sample. What you will do, simply you take the sample from the main road. But still it is coming under the GN division. Do you think it is a correct way? Soulmita, do you think it is a correct way?
No, sir.
No, why? Because you are a statistical officer after graduating. You are where are you from?
Jaffna, sir.
Jaffna, right. So you have been assigned under the GA Kilnochi. You asked to do the sampling as a census officer. You took a decision to go to 104th number house. Suddenly you cannot go. You are with sari and all, so you cannot walk in. So what you will do? So you cannot walk because you'll have to go because no vehicle can go. Only footpath is available. How do you go then? No other choice, isn't it? No other choice, because as a government officer, you cannot just go on the barefoot. If it is a vehicle available, you can go. Otherwise, no way. So what you will do is, instead of this house, you will take 1 or 2 samples here. So this is the problem sometimes arises when you come to this wrong procedure. This is called as wrong procedures. One of the wrong procedures. This wrong procedure, by knowing or unknowing, both are possible. In this case, it is by knowing. This case by knowing, right? So that we cannot blame anybody, but that is also possible. Ultimately, what is the problem? If you take the sample mostly from this main road, What is the problem? If you take the sample from the main road, mostly, what is the problem? Why? What is the problem? Yes, Solmita? Shalomita? Yes? What is the problem? If you take the sample from the main road, do you think it is going to represent the population? No.
No,
Yeah, it is not going to. Yes?
The people are in the not near the roadside. They have faced many problems to get the facilities.
Yeah, for example, this is not going to represent the population. Why? People who are closer to the main road, they are rich people. They are rich people basically. The people who are in the periphery, they are normally they are low in income or less in income, right? So if you take the sample, this sample is not going to represent the whole population. So that is the biasness. So that is why we say that is not a good criteria to take the sample. So when you do the sampling, important. So this you will learn more and more once you come to your final year research, right? Right. There are some advantage and disadvantage of this system, simple random sampling. Minimal knowledge of population needed. External validity is high, right? If you do it properly, yeah. If you do it properly, internal validity is also high, and statistical estimators of errors. So statistical estimation of error is minimal basically if you do it properly. Easy to analyze the data. On the other hand, there are some disadvantage, very high cost, because sometimes to search for one house, you may have to travel here and there, right? So because it is a random, anything is possible. Maybe one house is in this corner, the other house is in the other corner. So traveling time, everything is high cost, right? Requires some sampling frame. That is also important. It does not use researchers' expertise. Large risk of random error than stratified. Stratified, the term stratifying mean, I will come to that. That is the next type of sampling. Stratification. What do you mean by stratification? The second type of sampling, stratification of random sampling. What is stratification? Stratification. Stratification mean in Tamil, verupaduttal. In Sinhala, venkirim. What do you mean by stratification, random sampling? Could you remember earlier we said males and females, right? Males and females are there. What is the problem? In earlier example, 20 female selected, 5 males also selected along. So we said the number of females selected in random sampling is high compared to male. It is not going to represent the population. So that problem is there, right? So therefore, we have to cluster. Another term, we'll have to divide into groups. Then within the group, we can do the sampling. First, we divide the group. Then we do the sampling within the group. For example, we divide the group into male and female. Then, suppose out of 400 students, let's say out of 400 students, in our previous example, Faculty of Agriculture, out of 400 students, right? We have, can you all see this color? Is it okay?
Yes, sir.
Okay. So 250 female students, then 150 males. So you see 250 female student, 150 male student. Now I want to take 50 sample. What is the best way? Can somebody tell me what is the best way? Because if I could have done in an earlier way, simple random sampling, I may go wrong. Maybe choosing more female or choosing less male will lead to a problem. Why? Our estimate is not going to be unbiased estimate or precise estimate, right? It is going to be biased and unprecise. Therefore, now I am applying a technique called as stratified random sampling, male separately, female separately. What is the best way? There are different techniques available.
According to the percentage.
Yeah. Suppose, let's say, if I out of total number, how many females are there? 250. So out of total number of students, 250 females are there. So
Then
out
out
of
of 50,
how many do I want? So what is the answer? Yeah. Roughly is for female. You have a digit number. What is the value? Anyone?
31.25.
30?
1.25.
Right. So similarly for male, you can do it. All right. So that is equal. You will get an answer like this. So here we can approximate this to 31. We can approximate this to. So what do you mean by here 31 and 90? Now I have separated male and female group. I can take 31 samples from the female group and take 19 samples from the male group. So this is called as stratified random sample. Why still we have done the stratification? This is called stratification. Still we call as random sample. Why? After deciding the number, how I am going to choose this 31 female students? Now apply the same rule as earlier. Simple random sampling, you simply choose 31 students out of 250 because female students. Similarly, randomly select 19 students out of 150. So now we are applying a randomness after grouping as female and the male. Is it clear? So this is the concept behind the stratified random sampling. So I will just go through the notes. The basic idea, stratified random sample is obtained by separating population elements into non-overlapping groups, which is called as strata. So these are called as non-overlapping groups. Do male overlap with female? No. Male is separate, female is separate. So we are dividing into non-overlapping groups. This is called as strata. This is called as strata. And selecting a simple random sample from each strata. So this is what I said. After selecting the numbers, then this number can be selected from each strata separately. The idea of stratification is simple to blocking in experiment. So once you come to the final year, you will learn more about this blocking. Now your 4-1 is learning blocking. What is what it is. So blocking is a kind of controlling the variability up to a certain level, right? So that you will learn later. Reason for stratification, why we want to group it. If the group is not homogeneous, so in this case group is not homogeneous, you have higher proportion of female, lower proportion of male. Suppose if you have let's say 200 and 200, no problem. If you have 200 each, right, 200 male and 200 female, then we don't mind applying simple random sample. But if the group is different in size, then we have a problem. This is not only true in this case. For example, if you go to plants, right, some, even if the plants at the nursery stage all are looking uniform, but once you come to the field, some plants are growing taller, some plants are same species, same variety, etc. Everything is same, but they are growing at different level. Breeds, for example, you have the same breed animals, right? Same breeds, everything is same, but once you come to their weight gain, differs, right? So likewise, it becomes strata. So we can divide maybe the same breeds into one strata and so on, right? So to gain the precision, this is possible by dividing a heterogeneous population. So this is called as heterogeneous population. Why? This 400 is called as heterogeneous. You have male and female, heterogeneous. So we bring them into homogeneous, male separately, female separately, into strata in such a way each stratum is internally homogeneous. So heterogeneous, we try to bring it into homogeneous condition before doing the random sampling. So that is the concept behind gaining the precision. To accommodate administrative convenience, that is also possible. As I pointed out, when you do the sampling, right, questionnaire survey, GA division, AGA division, then you have Gram-Nalladhari division, so subdivisions. Those are called as administrative divisions, right? So to give the framework for the administrative divisions, we have that concept. For example, I want to take sample from Kilnochi and Jaffna district, right? I want to take sample from Kilnochi and Jaffna district. Can I take the same size of sample from Kilnochi and Jaffna? Can I? Akil, are you around? Mohammad Akil? Kamaldeen? Akil? Akil, are you around?
No, sir. He left the course.
He left the course. Okay. Then Vidushika?
No, sir. We can't get the same sound from just 9 p.m.
I couldn't hear. Are you Vidushika?
Yes, sir.
Yeah, I couldn't hear properly. Can you speak loudly?
Yes, sir.
Yeah.
We can't get same type of samples from.
Okay, from Kilnochi and Jaffna. Why? You are correct. Why?
Population may vary.
Exactly. So if you take, suppose if I want to study the farming population, definitely the size of the farming population in Kilnochi and Jaffna are two different values. They don't have equal values. And not only that, the Kilnochi farmers are having a large extent. The size of the land is a large extent. You cannot compare with the Jaffna farmers. Jaffna farmers are having a small extent of land area. So likewise, there are so many differences, right? In addition to this administrative districts, Kilnochi is a separate district, Jaffna is a separate district. Even though other problems are also there. So we stratify that, right? Fine. and we can ultimately we can save the cost as well to obtain the separate estimate for strata. That is also another objective. Rather than studying Jaffna district and Kilnochi district together, if I study these two districts separately, is it more informative or not? Yes or no? Which is more informative? Studying Kilnochi and Jaffna together or separately? Which is more informative?
Separate.
Separate.
Separately, yes. We can recommend and address Kilnochi farmers separately than Jaffna farmers. So, I mean, that is one of the good thing in stratification, to obtain separate estimates, separate results for these two strata or any number of strata. To accommodate different sampling plans in different strata, right? To accommodate different sampling plan in different strata or sampling in a certain strata. So we can have different sampling techniques. That is also possible, even though we say stratification, but we can do. Some of the stratification can be done even after doing collecting sample. Sorry. Some of the stratification we can do after selecting the after collecting the sample. That is also possible. It is called as post stratification. It's like a post mortem, right? After death, you do the experiment. I mean, examination, which is called as post mortem. Similarly, in statistics also, after collecting the data, we can do post stratification. You cannot do for all the data, but for certain data, we can do the post stratification, right? Do you understand what do you mean by post stratification? After collecting the data, we can separate into different groups, for example, right? Suppose, let's say, I have taken 100 sample from Kilnochi farmers without giving any priority to the size of the farm. After collecting the data, I can divide them into different groups. One group is above 5-acre farmers. The other group is 2 to 5-acre farmers. The third group is less than 2-acre farmers. Right? So automatically I have 3 groups. Initially I didn't think about it, but after reading their answers, questionnaire, now I have decided to group them, study them separately. So that is called as post stratification, because at the beginning I didn't think about dividing farmers based on the land extent. So I simply collected the data. After collecting, I divide the group. But what is the problem there? Sometimes you may have small size samples for some strata, some group. You don't get very large number of samples for each 3 groups. Is it understandable? So that is called as post stratification. විලංගුදු ආකලක විලංගෙලියෝ කට්ටියට තේරෙනවද? පැහැදිලිද? මම කතා කරන ඒවා පැහැදිලිද? සබ්ජෙක්ට් එක තේරෙනවද? මට ආකලක විලංගුද? Do you understand what do you mean by post stratification? That is done after collecting the data. That is also possible in this stratification concept. ஒருத்தர் மோவான்னு சொல்லல விளங்கிட்டு கம்சவதனி
Yes, sir.
பேர் சொல்ல வேண்டிய கிடக்குது இல்ல யா මේ වත්සල වතුර තියෙනවා right right, systematic sampling. This is a little bit different type of sampling. It's a very simple or stratified in nature. Systematic sample, it combines these two together. Systematic in picking up of elements. Example, every 5th house, right? For example, if I am doing sampling, I'm walking along the road. You have the houses. So pre-plan, I am selecting the every third house. See the first house, second house, third house. Every third house, right? So I am doing the sampling every third house. How to decide every third house? That depends of the researcher. If I have some formula, I will show you. So always, so this is yeah. This is the third house. Every third house has been selected for sampling. Not only house, maybe if you have plants. Let's say I have a chili plant. I want to study some diseases of a farmer. He is having a massive 1 acre chili plant, that particular farm. In 1 acre, how many chili plants are there? 1 acre, how many chili plants are there? Roughly? In 1 acre, how many chili plants are there? 1 acre. What is the spacing of chili plant? Bhairavi? How many chili plants are there? What is the spacing of chili plant? Ushara?
16 to 45.
30.
I couldn't hear. 60?
60 to 45 centimeter.
60 into 45. Yeah. So roughly, what is the square meter? 60 is 0.6 meter into 0.45. Isn't it? So 60 means 0.6 meter into 0.45 meter. So roughly about, can somebody calculate and tell me exactly what is the value? 0.27.
Yes, sir.
That much of square meter. In 1 hectare, so that is a plant, one plant spacing. So in 1 hectare, how many plants are there?
37.
Huh?
37.
No. In 1 hectare, how many plants are there? 1 hectare.
37,000, sir. Near with it.
Yeah. What is that?
37,337.
Okay, roughly, let's say
30,000.
Yeah. So if you say this is 0.25, 40,000 plants. 0.25, 40,000 plants. Let's assume I have 40,000 plants. 40,000 plants. In 1 hectare, I have 40,000 plants. How this chili plant is planted? Is it broadcast?
Row seeding.
Yeah. How? Row seeding?
I mean,
Row planting, not seeding.
Transplant.
Yeah, because you have nursery and so on. Yeah. So this is how you plant it, isn't it? Am I right?
yes, sir.
Right. Good. So this is maybe between row spacing. This is within row spacing, right? That is how spacing comes. I'm not teaching spacing, but just for our information. Now, I want to select only 200 plants out of 400 plants, 40,000 plants. Out of 40,000 plants, I want to select only 200 plants. All right? I want to select only 200 plants. What is the system that I am going to use? What is the system that I am going to use? Because out of 40,000, I want to select 200 plants as an example on this systematic sampling basis, right? Keep that in mind. let's look forward. I have a chat. Let's see. Yeah, okay. So answer is correct. Somebody has already given 37,000. Fine. Yeah, I assume 40,000 plants are there, right? Now, few steps. So this 40,000 plants, you can number 1, 2, 3, 4, 5, and so on. What is the total number of plants? 40,000. So this n in our example, n in our example is 40,000. 1 to 40,000. Is it clear? 1 to 40,000. Is it clear? What is this simple n in our example?
200, sir.
200. So the ratio between this capital and simple n, that decide what is the interval in deciding how many.
200, sir. That's all.
Yeah. So capital N divided by simple n, how many plants that can be skipped, right? That is can be called as K. So capital N divided by simple n, that is again 200, isn't it? Select. So that means in our example, according to this, our example, we can select. If I select this as a first sample, that is the first sample. What about the second sample?
After 200 plants, we can see.
Yeah. So let's say this is number 2, number 3, number 4. Likewise, you have the number. The 200, let's say this is the 200 plants. So that will be the second sample. To go on a systematic. So that is in simply called as systematic sampling. So that is why we can use that formula if necessary. Right. So this is just for your information, right? Select an integer between 1 and k. K is the k is actually in your case k is 40,000 divided by 200. I didn't use 37,000 because easy to divide for us to get an example. So this is 200. K is 200. So 1 to 200. That means sample size. So we so the jumping in our case the total sample also 200. The distance between the first sample and the second sample also 200. So this choosing the first sample is always random. I can start from anywhere as I want. Maybe from first sample or second sample, third sample, fourth sample. Right? I can start from anywhere I want. I can start. That is called as stratified random sampling again. Right? Sorry, systematic. The name itself, you could see systematic. It is also called as systematic random sampling. Even though systematic, how does it? It is also systematic random sampling, right? Why I'm saying randomness is choosing the first plant is always random. I need not to start from first plant. Suppose I'm starting from 150th plant. Let's say I'm starting. My first sample is 150th sample plant. So what is the position of the second sample? Anyone?
350.
350.
Exactly. So the second sample at 350. So starting point not necessary to be 1 always. You can start anywhere as you like. So for starting, to give up a starting, it is a random. I can choose randomly the starting point. Now I have choose randomly starting point 150. So my second sample, this is my first sample. My second sample, let's say this is 350. Second sample. So likewise, I can go around, right? So only the starting point is random, right? Only the starting point is random. Why only the starting point is random? If I have chosen my first sample, can I decide the rest of the sample where it's located? If I have chosen the first sample, can I decide the rest of the sample where it is located? Yes or no?
Yes, sir.
Yes, because all are depend on that calculated value. If I have chosen 150, my second sample will be 350th plant. What about third sample?
550.
Exactly. So after deciding the first sample, it goes on. So choosing the first one is the random. The rest of the sample selections are not random. It is systematic with the equal gap. Right? This is elaborated. It's the same thing I have elaborated. You have 1 to 100 number. Capital N is 100. Simple N is 20. 100 divided by 20 is K is 5. Every fifth member will be selected as the sample. So what is my first sample?
Number 1, sir.
Number?
1.
No.
Fifth sample means every.
What is my first number? First sample? I didn't choose one as sample because the gap, look at the gap.
Number 4.
Number?
4.
Number 4.
Exactly. My first sample is number 4. After selecting number 4, automatically the rest will be selected. After 4 gaps, sorry, 5 gaps. 1, 2, 3, 4. Fifth will be next sample. That is 9. Right? So here, ninth will be the second sample. Then you have 5 gaps, then 14 will be the third sample, and so on, so on, so on, so on. So you see, this is the last sample, 99. Look at after 99, the gap is same. After 99, 100, 1, 2, 3, then 4. It goes as systematic. Any questions on that? Yeah? Any questions? Any questions? I will give you a couple of minutes. Any questions? You can unmute your microphone and ask any questions. Don't forget that we are going very slowly, right? Actually, what I have done for last 2 days, even though it is 2 + 2, 4 hours lectures on Zoom, by normal in-class lectures, it is only 2 hours, less than 2 hours, right? So don't count the same hours of lectures of Zoom as in-class lectures. Do you understand? Is it clear? Don't argue with that because this is a statistics. I am not reading the what do you call the screen all the time. I try to explain maximum as possible where you can understand most of the concept. Is it clear? Kamsavadani. Don't come thereafter with saying, sir, you have covered 23 hours, 24 hours. I'm trying to give you a good knowledge in statistics, beginning, because this is the only subject that you learn newly. The rest of the subject you have done in A level up to a certain level, right? Am I right?
Yes, sir.
Yeah, because unfortunately only Kamsavadana is answering because I cannot catch other people. But if it is in class, yes, I can catch you all. No problem. Right, any questions? I will check with the chat whether is there, because we will stop here. Any you can write any questions. Next week maybe we can have two classes, huh? Maybe Wednesday and Thursday, I'm not sure. Wednesday class is fixed, right? So tomorrow, what about your availability from 10 to 12? Huh? Yes, comes with any availability?
Yes.
What are the courses that you all have already started?
Animal science,
Yeah.
agronomy, Jeevan sir.
Okay.
Biology, Vairudan sir and Thirukumaran sir.
Okay. Biology. And
Aquaculture.
Aquaculture. Economics?
Economics also. Today's.
Okay. I will see whether I can come tomorrow as well, because tomorrow I'm not sure if I have some other work, I will not come. Anyhow, give me a ring, Kamsavadani or Jeffrey around 9 o'clock, then we can confirm. You don't need to worry if the same numbers. Huh? I mean, same password and ID will be used. Huh? Right? Any questions? Any questions? No questions? Everybody is satisfied and saturated, huh? Am I right? All right. Okay. See you then. Definitely we will see you next week, but I'm not sure whether I will be able to do it tomorrow. Anyhow, Kamsavadani or Jeffrey call me tomorrow by around 9 o'clock, so I will confirm. Huh? Right. Okay.
Yes, sir.
Okay. Thank you. Bye.